geology sector. Mr. Sunkari, please, if you can hear us, you can go ahead.
All right, thank you so much. Let me try to share my slides. The slides are open, but I'm not seeing. Okay. Just give me 1 minute. I have to reopen this slide. Okay. Please, can you see my slides?
Yes, Doc. From my end, I can see. I don't know if the other people.
Putting it on slideshow.
Yes, please.
So please, in case you can see, you can give it thumbs up.
All right. Is it on slideshow, please?
Okay, is there?
Not yet.
Is there? Is there?
Slideshow at my end. Hello, can I proceed?
Yes, Doc, you can.
All right. So thank you so much for the introduction. So as you rightly mentioned, I am presenting on, let me try to put my video on. Okay. So I'm presenting on the topic leveraging medical geology to achieve the sustainable development goals, bridging health and environmental sustainability. So throughout my presentation, these are the things I'll be talking about from introduction all the way to the acknowledgements. So when we hear about medical geology, what comes to mind? If you go into research or into literature that is available, you would get to know that medical geology is actually an old and a re-emerging field of science, and it deals with elements of earth science and public health. And looking at the goal of earth science, it is usually geared towards deciphering the impacts of geologic phenomena or geologic processes and how they affect human beings and the earth in which they live on. So some of the issues that medical geology deals with are toxic and deficient levels of essential and non-essential minerals. When we were growing up and we were in the high school, we were taught about the minerals that are essential for the human body. So medical geology looks at some of these elements when they are in their higher concentrations. What happens to you? Now, when we go into deeper levels of medical geology, you realize that it is even said that everything, even the food you eat, is a poison, because when it is in higher dosage, it can become something deleterious to your body. But in medical geology, we are dealing with the geologic aspect, how geology contributes to human health, all right, or how the rocks and the processes that lead to the formation of the rocks and the minerals affect the health of humans. So the goals of medical geology are to identify sources of health hazards in the geologic environment, and which will help in prevention. But for medical geologists, we do not do the prevention, or we don't do curing. We only look for the sources of the contaminants. Now, we want to live in a very sustainable ability and that of health to reduce, improve the efficiency. Assesses the complex relationships between the environmental factors and their impacts on humans. If you look at this, we have what we call geogenic contaminants, meaning contaminants coming from geological sources or they are natural in nature. So what happens is that they spread into various spheres of the earth. They can enter into the atmosphere, into the hydrosphere, into the lithosphere where we have and soils and even the rocks. And then they get to water resources, get into animals like the livestock, the fishes, and then even in our farms, on farmlands. And in the long run, they are going to affect human beings. That is how affect human health. So all these things, if you want to study how the geogenic contaminants enter into the various spheres, you would be achieving a few of development goals. They are actually described as a to-do list for the planet that we live on. Because if you look at what Ban Ki-moon, the former Secretary General of the United Nations, he said it is a to-do list for the planet that will transform the world. That is how come they came with the Sustainable Development Goals. And they were adopted by the United Nations member states in 2015. And they are 17 in number, and they are integrated. And one thing they do is that they recognize the action in medical geology deals with how the geogenic environment or the geology and geological processes affect the environment, including the humans that live in the environment. We have earth materials like the rocks and the minerals, and some of them are poisonous. When you eat them or they get into your system, they can serve as a threat to your livelihood. So medical geology deals with knowing the sources of those contaminants coming from the geogenic sources. So that is what medical geology is all about. And we're trying to link it to the Sustainable Development Goals. I stated initially we had MDGs, but most of the MDGs did not consider environmental issues. The targets were not clearly defined, like how we have the SDGs, especially SDG 6, which has several targets on clean water and sanitation. So things like emissions of greenhouse gases, access to clean drinking water, and management of water resources were not considered in the MDGs. Then that is when stakeholders began to now develop a new focus and a direction towards the concept of sustainable development. And then the SDGs were incepted, and they started looking at the relationship between nature and society, how the various things within the earth affects our social outfit, environmental, and then our economy. So 17 sustainable development goals were propounded, and you can see all of them starting from no poverty all the way to partnerships for the goals. And I indicated that all these sustainable development goals are geared towards achieving certain things. For example, environmental protection. We have goal 6, goal 13, 14, and 15. They are all geared towards protecting the environment. Life below the sea, life, up on the land, and then water and all that, sanitation, all is about environmental protection, which is within the biosphere. Now, some also have something to do with social inclusion, all right, no poverty and all that. Goal 1, 11, 16, and 7. Then others are addressing the society, okay? So we have 8, 9, and then others are going towards the economy. The same 8 and 9 go towards the economy, especially economic growth. We have goal 10 and then goal 12. Now, what is medical geology? Medical geology, or others will call it geochemistry, medical geochemistry, actually, comprehensively looks at the effects of geochemical processes and geological factors on the health of humans, on the health of plants, and the health of animals. Previously, some scientists had it as medical geography. It used to be called medical geography, but medical geography does not focus on the underlying geology. It only looks at the geographical distribution of diseases. For example, we want to know the distribution of, let's say, malaria or any disease that is caused by human contaminants, natural contaminants. Let's forget about malaria. But if we have a disease caused by natural contaminants, and we want to know where it is in Ghana, where it is located or is dominant in Africa, then that is medical geography, or others will call it geomedicine or geographic medicine. But the new field that has emerged, which we call medical geology or medical geochemistry, actually looks at the effects of geochemical processes and geological factors on the health of humans, animals, and plants. So it's an interdisciplinary field that involves a lot of people or diverse areas or disciplines. Geology, environmental geochemistry, we have people who are into toxicology, biology, hydrology, and nuclear analytical techniques. They all come into play to achieve the goals of medical geology. So in brief, medical geology or geochemistry is the study of interaction between abundances of elements and isotopes and the health of humans, animals, and plants. Now, one thing you need to know, according to Hippocrates in the 5th century BC, he said, if you want to learn about the health of a population, look at the air they breathe, the water they drink, and the places where they live. If you want to just assess whether people are living in a good, healthy environment, these are the things you need to look at. So medical geology also envisages all that. The scope of medical geology is such that it is wide. It looks at things from planetary view, from the whole planet, to microscopic view, because we have to even take some of the things from the earth and study them under the microscope to understand patterns, because in medical geology you are dealing with elements, you are dealing with minerals and how they are affecting the human body. Now, medical geology deals with the cause of the disease and not the cure. So I must state it clearly that it's not a curative discipline, but it's a discipline that unearths the causes of diseases. That is what we need to know. So don't say, I want to be a medical geologist so that I will start curing diseases. No, you would be looking for the causes of diseases. Okay, sorry for the technical hitch. So let's move on because we don't have time. So we want to look at the sources and exposure routes of contaminants. How do contaminants get into the human system? So the sources are from the soil, then from the water, from air dust, even from food, we can get some contaminants, and all are going into the human system through several ways. Exposure routes through dermal absorption, ingestion, we eat, then inhalation. All right, and all these are going to the various parts of the body, and they'll be affecting certain parts of the body. So now, when these contaminants get into the system of humans, they are able to cause three major things. The first is they are carcinogenic, meaning they can cause cancer. So some of the contaminants cause cancer, like arsenic. Some are teratogenic, they can cause birth defects. So you give birth to a baby and the baby is stillborn, or the baby has defects, the hand, the leg is not well formed. That is teratogenic. Then mutagenic, some can cause genetic mutations or change the genes within organisms. So these are the things that happen when you have contaminants into the system. Now, environmentally, we will say contaminant sources are divided into two: point sources and non-point sources. When we say point sources, they are the ones you can easily pinpoint where they are coming from. So, for example, over here, maybe storage tanks and landfill sites, pipeline discharges. But the non-point sources are the ones coming from agricultural activities largely, and runoff is what usually carries them. But in terms of medical geology, we are looking at those that are from geogenic sources within this particular environment. So the contaminants can come from, several ways, as I told you, from mining activities, coal mining, and all that. They can come from dust particles, they can come from the soil, from sediments, and they run into the water bodies, either surface water or groundwater. Some can come from even rainwater, because the dust that is contaminated can get into contact with groundwater, rainwater, and then you harvest it and drink. Then it gets into your system, your drinking water gets into the crops. We even irrigate some crops with some of these polluted waters, and it is getting into our system. There is another term we call geophagy, where people eat soil or people eat, earth materials like clay. I will show you some pictures. pregnant women, especially in northern Ghana, when we were growing up, they used to eat what we call clay. They call it chile. So this clay that you are eating, you don't know the chemical makeup of the clay. It could contain some contaminants which may be carcinogenic, teratogenic, or mutagenic, but we eat them. So look at this. You go to the market, people are selling the chile or clay, and some even eat clay for some healing effects. They will dissolve it like this and grind it into, powder, add some water, and becomes, something slurry. Then they eat it. Look at the chile or the clay, they eat it, but you don't know the health effect of it. Now, diseases come from several sources, from environmental activities. So viruses like this, when COVID-19 came, we were told to be hygienic. So diseases can come from environmental sources, or some could be genetic. So hereditary, your father or your mother had a disease and passes it on to you. And some could be due to our lifestyle, what we do. As we smoke, we drink, we eat, our eating style can also even bring some diseases to us. But what we are saying is that all these will represent an imbalance between chemical elements and the body. Now, when you look at the periodic table, there are some elements that are earmarked as essential to human life. For example, vanadium, chromium, manganese, iron, and all that. But when they are in excess, they become poisonous to the human being. And some are actually even delineated as potentially toxic. All right? Palladium, cadmium, mercury, uranium, arsenic. These are potentially toxic elements, and they can lead to these carcinogenic effects we talked about. So we have these elements and patterns, how they move. So macronutrients involve all these elements you can see here. When you lack them, there is a problem. But when they are in excess, there is no difference. You don't have any problem for any of these elements. Now, for the essential micronutrients, when you lack them, sometimes you may have some problems. But when they are in excess, it becomes toxic. It becomes lethal to you. For example, arsenic, you could have some cancer of the skin or the blood. Then those that are not essential, as for them, you don't even need them in any threshold or amount higher than the guideline value. The moment they get out of hand, then it becomes a problem. So metals like mercury, nickel, lead, antimony, tin, and all that, they are metal. So these are the metals that we have which are toxic, and the target organs. All these metals can come from earth materials, from the rocks, from the minerals. Arsenic like this can target the bladder, the liver, the lung, and the skin, and can cause a lot of problems. Look at mercury. All these elements, the reason I'm taking out arsenic and mercury is because of the galamsey activities we have in Ghana. And these galamsey activities are releasing these elements into the water, into the soil. Now, mercury can cause brain damage. It goes to attack the kidneys, the lungs, and it can also cause neurological changes. Look at some of the problems that people are encountering because of arsenic-induced toxicity. So if you have high arsenic in your system, maybe from the food you eat, the water you drink, you can have skin pigmentation like this, all right? Or we call it keratosis. Then you can also have Bowen's disease. Then we have something we call squamous cell carcinoma. Look at this, something very hardened, but it spreads all over your leg. Then basal cell carcinoma. Look at somebody's skull. You have sores all throughout. Some of these sicknesses we are encountering, I tell you, they are coming from potentially toxic elements. Look at this also, suite of elements and what they cause. Cardiomyopathy for cobalt, selenium, and then mercury and the others. Then look at iron and selenium. When they are high, you can get these kind of sicknesses. Now, hypertension that people are suffering from globally and also in Ghana, if you have high amount of arsenic, mercury, and lead, and as well as aluminium, it can lead to hypertension. And for lung diseases, asbestos, these are things that come from natural things, from rocks, from the minerals. They can cause all this. Beryllium can cause presence of granulomas. And then iron deficiency or excess of iron can cause cirrhosis or silicosiderosis. These are things those in the medical field will understand. Now, there are some that we need to take note of, especially those of us living in the northeastern part of Ghana, northeast region, upper east region. This is very common. I've presented in the previous webinar before. Fluorosis is a big problem, dental fluorosis. The water has high fluoride, and this fluoride is mottling the teeth of the people. So the teeth becomes brownish or yellowish like this. Some of them, even the legs, become bow-legged like this. We call it skeletal fluorosis. It's not only in Ghana, it's in India, Bangladesh, Nepal, and most of the parts of Asia as well. So, and even iodine. You see, we have this very common among people in the rural areas. So when you lack iodine, you can get goiter or cretinism. Now, this iodine also comes from earth materials. That is why it's a medical geology issue. Now, diseases due to deficiency, sometimes it's not always all about high amount, but the low amount of some of the elements can also cause some problems. So for example, cobalt can lead to heart failure, low amount of cobalt. Low amount of chromium can lead to kidney damage. Now, what about zinc? It can lead to metallic fever. These are all things that we need to know. So geology plays a key role in promoting the SDGs. If you look at most of the areas of geology, geophysics, hydropower, geomorphology, GIS, and remote sensing, you can use all these, for example, to map where you have these rocks that may be containing minerals that are poisonous. Planetary geology, you can study the planets and know what they are emitting and which is poisonous. All this, so you can see that geology plays a key role in achieving most of the sustainable development goals. But I'm not here to talk about just geology. I'm here to talk about medical geology. So what about medical geology? How does it achieve the SDGs? Medical geology plays a key role in promoting the SDGs by addressing the complex interplay that occurs between the geological factors or geological processes and human health. So you can have rocks weathering into water, then they release their minerals, and the minerals also weather further, and the elements are released into the water. You take it and it may affect you. Then the rocks can become soil, you plant on them. Now maybe the potentially toxic elements that are in the soil, the crops will bioaccumulate them, and then animals will even feed on the crops. The animals will also get that in return. Yes. So even from the atmosphere too, you can have contaminants coming onto the surface, then from the sea as well. So all these are medical geological things. So let's look at the role of medical geology in achieving selected SDGs. It's not all the SDGs, but at least a chunk of them have something to do with medical geology. So for goal 1, which is geared toward achieving no poverty, I mean, we don't want to have poverty, we want to eradicate poverty throughout the world. So by identifying where we have health risks coming from geologic materials, we can actually, plot or generate maps advising people about where we have vulnerable areas and people will not be cropping on them or farming on them. And when this is done, poverty will be reduced. Once you farm well and then you get good crop yield, you can sell money, then poverty will be eliminated. So this also looks at ensuring access to safe water and healthy environments. So we can actually depict where we have high fluoride, high arsenic, and all that through medical geological research. And that is also achieving SDG 1. What about SDG 2, zero hunger? Now, medical geology will actually help in understanding soil composition. You look at this farmer, he's taking soil sample. Medical geologists, we do that. We analyze the composition of the soil and we know whether the potentially toxic elements are in the soil and they are affecting the soil quality, affecting the crops that are grown or not. So that is the role of medical geology in achieving the SDG 2. You can see me, this was in Dakurupe where they are doing this artisanal small scale mine in Galamsey. It's dominant. So they were using, how do you call it? Cyanide to trap or catch the gold. Now this cyanide is leaching into the soil. So we were interested in taking samples from the soil to do analysis and understand the pattern. Now, you can also plot maps of various elements in agricultural soils. If you take samples from the various soils in the earth, you can actually plot maps to tell us where you have higher values. For example, the red portions showing that these are dangerous areas with respect to arsenic, with respect to lithium, okay, in agricultural soils. When you do this, you are solving a problem. It's just towards achieving SDG 2. And this is where agrogeology comes into play. So it's an emerging field. I heard University of Energy and Natural Resources might be starting something like that. Agrogeology as a new program. It's an intersection of medical geology and agriculture. All right. So you will be able to know how the soil is healthy for plant growth. Now, what about SDG 3, good health and well-being? If we understand the geochemical processes that affect the soil that we plant on, and then the water that we drink, medical geology will contribute to reducing exposure to harmful substances by improving the public health. So, for example, we have things coming from anthropogenic sources on the surface, they go down into the ground, and then they pollute the groundwater. Right? We do industrial activities like mining, or even the rocks, they can weather, and then erosion occurs, and then their chemical constituents are brought downwards into the subsurface and contaminate the groundwater. Now, what about SDG 6, clean water and sanitation? With medical geology, we are able to investigate and actually offset the impact of geogenic contaminants. For example, heavy metals or potentially toxic elements and radionuclides on water quality, and this will make sure that we have safe drinking water for everyone. So, for example, in our studies, usually we can go and sample, water from boreholes and from surface water sources. Then we can test in the lab using some robust techniques, inductively coupled plasma spectrometry. Then we can analyze for these potentially toxic elements, and then we can do risk assessment, and we are able to come out with the fact that they are affecting the human health or not. So with this, we can put special distribution maps. For example, this is our recent paper about the fluoride in the whole of Ghana, fluoride contamination in Ghana. The previous webinar I had, the work I presented, it was published in Groundwater for Sustainable Development. And this is a complete map showing the whole of Ghana where you can have high fluoride in water. The red means it is high, above the threshold 1.5. And you can see it is predominantly in northern Ghana. There are some parts in southern Ghana, but it is less. So with this, we are able to advise policy makers, and then they can help in monitoring the quality of our water. Now, what about SDG 11, sustainable cities and communities? With medical geology, we are able to assess disasters, whether they will occur, what are the vulnerable conditions in the environment. Medical geology looks at that. For example, landslides, earthquakes, urban planning, all these we are able to do risk assessment through medical geology. Exposure to gases and all that, we look at all that. And then the vulnerability of the environment. Maybe you have slopes that are unstable, all right, because they contain some minerals or some rocks. This is an aspect of medical geology. So we look at all that. Now, I want to briefly give a description on how we can use medical geology to solve natural disasters or mitigate natural disasters. When a disaster occurs, we use two processes in mitigating it. We have what we call the recovery process. The moment the disaster occurs, let's say flooding, what you do is you have to provide relief to the people. Then you rehabilitate by providing the basic needs. Maybe they need to go to hospital. You need to give them certain things, all right, pre-disaster to bring them into their pre-disaster conditions. Some seed money to start something before you reconstruct whatever they have lost. Then the next stage is reconstruction, which is still within the recovery process. That is where you will now put buildings that are safe and will be able to withstand any future disaster. Then the next stage is the protection stage, where you are thinking about the future. You prepare the people towards future encumbrances. Do this, you do mitigation. It is a form of preventative action for risk reduction. Then you have to put some insurance policies in case something happens. This is what you will do. So these are all the things you do in medical geology or environmental geology to actually mitigate disasters. Now, what about SDG 13, climate action? This is the talk of the day. We have COP28, COP30, and all that. Every year they go for these conferences. So research in medical geology helps in understanding the geological aspects of climate change. For example, carbon sequestration. Carbon is being trapped into the atmosphere, or carbon comes from several sources, and it is affecting, the quality of life. It impacts natural resources, greenhouse gas emissions. They are all coming from the activities we are having, and they are affecting the quality of life. With medical geological research, we can get to understand the source of some of these greenhouse gases. It's not all of them that are coming from human-induced sources. Some are coming from rocks and minerals. We have radionuclides, all right? Medical geology plays a crucial role in achieving SDG 13 through the identification and mitigation of health risks associated with environmental changes, which are induced by climate change. Now, SDGs 14 and 15, life below water. So we have some animals that are living within the sea, and then on land, we, the humans, and even the animals, and also some plants. So with medical geology, we are able to provide critical information about geological factors which are affecting water quality. So we are able to know that in northern Ghana, because we have a lot of granitoids, especially the Cape Feldspar Ridge Bongo granitoids, they contain mica-bearing minerals like biotite and muscovite, which are dissolving into the water, releasing fluoride, and which is causing the dental fluorosis. You see this? Then we can also get to know even rocks beneath in the sea. In the sea, we even have mountains, we have rocks, and there is saltwater intrusion. Okay, so the seawater is very salty and it is intruding into groundwater sources. Medical geology can look at all these and advise people. Now, what about the last SDG, SDG 17, partnerships for goals? Now, I told you initially that medical geology is an interdisciplinary field. It involves people from diverse backgrounds. Please don't tell me because you are not a geologist, you cannot be a medical geologist. No. If you are in any of these areas, it's not even all these. There are several others, not just restricted to this. If you are into toxicology, you are into medicine, epidemiology, you are into geoscience, all right? So you are into genetics, people into biology, geomedicine, you are all part of us. Those who are even into public health, those who are into social sciences, because you go around to interview people about quality of life, how water is affecting their health, you are part of medical geology. You can be a medical geologist. So it brings together geoscientists, health professionals, and even policymakers to sit down and craft integrated solutions which can lead to what? Sustainable development. So let's take some case studies before I end the presentation. So my research team, which we call Applied Geochemistry Research Group, we've been able to publish over 50 scientific articles, predominantly in Elsevier and Springer Nature journals, on the various aspects of medical geology. And all these papers are promoting the SDGs. You can see the comparative analysis of fluoride in groundwaters in northern and southern Ghana. Then we also have fluoride issue in the Bongo area. Then we also have human health risks of fluoride and boron. This is the first time we are recording boron in Ghana, and it's especially in the northeastern part of Ghana. All these are addressing the sustainable development goals. Then also in the northern Ghana, especially the Kwewu-Bomboaka group, yes, when you go to northeast region and upper east region, northeast region predominantly and the northern region, you will see that we have high levels of fluoride in the water. Now, in the upper east region, we've even conducted a review on the complete water quality, not just groundwater, surface water and groundwater. And these issues were pointed out. Fluoride has been a major issue. Then we also have in Via catchment area, all right? The Via area also has fluoride problem. Then the same thing for Bongo and recently in Saboba. Saboba district currently, we have recorded fluoride concentrations up to 4.7 milligram per liter in Saboba. And one of our researchers, which is coming, has even recorded up to 19.5, which is the highest so far. Then we've conducted some even in South Africa. And then this is what I presented last time in our webinar. So these are some of the works we've done so far. So I'm just going to take a case study, a typical one, and then we conclude with that. So in the Voltaire supergroup, which is the largest sedimentary basin in Ghana, We try to actually look at the human health risks and the hydrogeochemistry of groundwater that is fluoridated in that area. We use a medical geology approach, which was multidisciplinary. In that area, the rocks are predominantly sedimentary rocks. So you can see here, we have sandstones, and then we also have some mudstones, which are intertwined or intermixed with certain, geological materials. This is part of the research of one of my students who graduated just last year. And the research was aimed at determining the physical parameters and hydrochemical characteristics of the water, to establish the minerals that are causing the enrichment of the ions, then to know the sources of the groundwater contamination and how they affect the mobility of fluoride, and to even know how much fluoride is ingested by the human beings and the possible health risks through deterministic and probabilistic health risks, methods. And then also we carried out community-based health surveillance to know what is happening. How did we do this? We conducted literature, collected some rock samples, because if you say the minerals in the rocks are the ones causing the fluoride in the water, how? There's a big question. If you don't sample the rocks and do mineralogical analysis, it is difficult to link that. So we did that. Then we also took some data from the World Health Organization that has been drilling boreholes over there. And then we collected some health information from the various health centers in how do you call it, Zabzu and all those places. We went there in northern region specifically, administered questionnaire, took borehole logs, and then we now analyze the data using some of these plots. We did statistical analysis. Laboratory analysis were also conducted, especially on the water and then on the rocks. So this is the student Onesimus who went to the field and collected the samples, did the analysis, and these are the borehole logs. If you go downhole, within each borehole, these are the kind of rocks you intercept from top to down. So you can see that we are having silty sand, mudstone, downwards, that way. Then sometimes we have shales and schist intercalated. We have gravels at the top. This is just the local geology of the area, and it agrees very well with the geology map we had. So these are the results of the mineralogical analysis, especially the petrography under the petrographic microscope. I told you medical geology is from global perspective to microscopic perspective. So under the rocks, we identify quartz, then some opaque minerals, which may be sulfides and chloride in them. There were certain instances we encountered zeolites, close to the opaque minerals. And then we had biotite filling in a fracture. And this biotite is the cause of fluoride, because biotite contains fluoride in its chemistry. Look at the chemical formula here. You see F here. If the F is released into the water, you are going to get what? Fluoride. Then we need to also use another robust technique to know the mineralogy. So we use XRD analysis, and these are the various minerals with their peaks that were identified. Quartz was dominant because we have a lot of quartz veins running through the area. Now, for the water samples, you can see that fluoride concentration was ranging from 0.5 milligram per liter. So about 27 samples out of 31 were having high fluoride, which is a very big issue. So with the water, in terms of cations, you can see that calcium was a dominant cation. I mean, sometimes magnesium also had higher values or was dominant in the water. Then bicarbonate was a dominant anion, followed by sulfate. Then in the area, when you go, where do you have higher concentrations of the various parameters we identified in the lab? This is what I was talking about. With medical geology, you are able to map and delineate areas of concern for stakeholders to take action. So in terms of pH, you can see that the higher pH values are the ones in red. So towards the northeastern part of the area, towards Gushebu, that is where we have high pH values. The rest of the areas are quite okay. Now, what about potassium? You see it scattered towards the northwestern part and some parts of the southeastern. And then we have the same thing for arsenic. Now, but these elements do not have problem. The major concern is the fluoride and then sometimes nitrate. So look at fluoride in the E diagram here. All the samples even have high values because there is none that is below 1.5. But at least with that, we still have low and high. So if you go to the northern region, the place with higher values of fluoride are in the Gushebu municipality. So Gushegu municipality is here. The rest of the areas also have high values, but still those high values are above guideline values and can still be having effect on the human beings there. So in the Mion district, in the Karaga district, you have the same problem. Gushegu is worse. Then what about nitrate? We read that some of the water samples even had higher nitrate, and this could be coming from the use of fertilizers and all that. Again, is dominant in Gushegu. And as you move towards Mion, you have that problem as well. So the water types we identified, which is owing to the interaction of the rocks and the water, is predominantly potassium bicarbonate and then magnesium potassium bicarbonate. This is largely because of the type of rocks we have in the area. I'm not going to bother you with all these diagrams. So we try to decipher the processes that are controlling the chemistry of the water. And we realize that ion exchange reaction all throughout, and then sometimes silicate weathering is what is actually controlling the chemistry of the water. When we say ion exchange, we have an ion of the same valency which substitutes with another ion of the same valency. Let's say sodium and potassium, they substitute with each other. Then you will see the sodium will be low, potassium will be high because potassium has come to substitute with sodium. That is what is happening in the water in that area. And because we are saying that it is geogenic coming from the rocks, you can see on the Gibbs diagram, all the samples are plotting in the middle zone, rock weathering dominance, meaning water-rock interaction is actually what is affecting the chemistry of the water. Then we try to decipher the source of the fluoride, whether fluoride goes hand in hand with the elements or parameters. You see that low concentrations, very low values, correlation coefficient values. But when you check fluoride and pH, in fact, they have nearly perfect correlation, very good correlation. That shows that when the pH of the water is more alkaline, as the pH increases, then fluoride values are also increasing. So pH actually controls the fluoride mobilization. Now, what about the minerals? Are they dissolving the water? Which minerals are dissolving, which are not dissolving? Now, we call geochemical modeling, and the various mineral phases we can have. For example, if we check goethite is iron-bearing mineral. Iron was of higher concentration. That's why goethite is showing saturation or showing saturation. That is to tell us that it has precipitated even in the water, and continuously it is influencing the chemistry of the water. The other minerals are undersaturated, but they show good correlation with fluoride, and they may be also contributing to the chemistry of the fluoride. So what are the sources of the contaminant that we've identified, fluoride? You can see we did factor analysis. The fluoride is in one group with some elements, with nitrate, with chloride, and then with pH. That is why fluoride and pH had very good correlation. It means that chloride also has good correlation with nitrate and chloride. So this suggests that the fluoride could be geogenic and at the same time anthropogenic in origin. We are taking fluoride-based, toothpaste. Some of the toothpaste have high fluoride. The reason we add fluoride to toothpaste is to reduce so that you can have good teeth growth. When it is high, it can cause a lot of problems. So it is seeping down into the aquifers and affecting. Now, we are also practicing agriculture in this area. So they are using fertilizers that contain fluoride and nitrate. That's why nitrate is there, and even chloride. So that is why we have these grouping here. So the fluoride and nitrate are geogenic and at the same time anthropogenic. Nitrate could be coming from phyllites, all right? Some people will say, how can nitrate come from rocks? It's only coming from fertilizers. Look, a substantial amount can also come from rocks, from mudstones and phyllites. When you have these kind of rocks in a particular area, they have some amount of nitrate that is released. The contribution cannot be compared to that of anthropogenic source like that of the fertilizers. So we did a health risk assessment, grouped the various ages in the three communities, two communities or two districts. There are actually three, Kara and Gushegu. So this is coming from the health survey we did, going to the health centers. Adults, the body weights were like this, teenagers and all that, the amount of water they drink a day. We took all that and we did the analysis. Now you will see that in Gushegu, the estimated daily intake, which suggests that the amount of water each age group takes which contains the contaminants, is what we are looking at here. So you can see that the age group, which is what? Children, green, they are the ones consuming more water with fluoride and the other contaminants in Chegu. The same trend in Karaga, the same trend in Nyon. All right. Then we talked about the hazard quotient. Hazard quotient is talking about the risk. How they drink the water with the fluoride or the contaminant, are they exposed to any risk like the carcinogen? I mean, this is not carcinogen. Hazard quotient, we deal with carcinogenic risks. So maybe liver or kidney issues that it may cause, or stomach upset and all that. We are seeing that because the children are drinking more water, they are the ones being affected throughout. So we had to do some Monte Carlo simulation to see what we got is right, and actually we're getting similar trend. Even though infants are also showing, higher dosages among the populace. But when we now increase the iteration to 500, you could see the same trend here. Our children are the ones actually being affected. So we can conclude that children are the most hypersensitive population in northern Ghana. So this is a map showing where you can have children or the various age group drinking amount of water with the contaminants. And it's showing Gushegu as the problematic area. Then the hazard quotients, whether they're exposed to carcinogenic risks, it is more in Gushegu, then some in Miao, and then we have others in Karaga. So from the field studies, this is what we got. It's not about just estimating or calculating, but field-based. So that's what we call community-based health surveillance. You can see the teeth of the people, all right? Then this one, we think it is skeletal fluorosis, see the leg of the child. So that's what is actually happening because of the water they are drinking. As I indicated in the previous webinar, the people are now resorting to surface water because the borehole water they are drinking is contaminated. It's causing their teeth to be like this. So they are now drinking this water. As they are drinking it, they have a lot of stomach issues, gastrointestinal problems, and then they are performing a lot of surgeries on them. And this is not really good. So let's look at the challenges and opportunities for medical geology. Data availability and quality is a problem. How to get the geochemical data. It is very difficult to do the analysis. Then interdisciplinary collaboration. As I told you, medical geology involves a lot of people. All of you that have joined this webinar today, you are all part of the branch of medical geology. We need all of you to bring your ideas together. Public awareness is a problem. There is general lack of awareness about the importance of geological factors in health. All the time we are looking at anthropogenic factors, okay, the activities we're doing, but we're not talking about the rocks themselves, what they are doing to us. Then resource allocation, limited finances is a problem. There is opportunity for growth. Improve public health, all right? If we are able to identify and mitigate geological health risks, medical geology can contribute to better health outcomes. And it will lead to attainment of most of the SDGs. Sustainable resource management, policy development, innovation, and research, they can all be done. So before I conclude, I just want to see, the list of the students I've trained so far in this field since, my assumption of duty as a lecturer in UMAT in Ghana. I've trained a lot so that we can achieve the SDG goals. This is the first international student. He did MSc Geological Engineering. In fact, that is his work I presented, excerpts of his work. All right, Onesmus D. Zion. Then we also have Raphael Kobena. He's working with Precious Mining Ghana Limited. He also did masters with me. We're looking at Fantiakwa area, the water quality there. Then we have Yvonne Otu. She also worked on Gushegu municipality in the northern region, especially fluoride and nitrate are having higher concentrations there. Then we have this guy, Kamaldin, worked in Nkwanta district. Then we have Harriet, worked in Oti region. In fact, we are spreading across all the regions so that we can make this work holistic. Then we have Karaga district. Celestina worked on it last year. So then we have we also work on soil. It's only about the water. All right. So the current explorations that are ongoing in the lithium field in Ewoya, we try to analyze the soil quality there. Daniel did that last year. Then Zagu district, high fluoride, the paper will be coming out soon. Then apart from just knowing the sources, we try to develop or design treatment technologies. So this lady, Kubi Grace, used moringa to remove the fluoride, and it was effective. Then Idris also worked on the Bunu East region, and we also have Upper West region, where I come from. We have high nitrate in the water. Nyamiche worked there. The same thing with Savannah region, all right? Caleb also worked over there. So we have a list of them. Strategy using cow to remove the excess fluoride in Northeast region. Charles worked on it. Prince Ado, who is at Angogo Dasha, also worked on the Bunu East region, all right? And then we have Moses Boachi Ochre. He worked on the Bongo district, and this is the hub of all this. Medical geology in Ghana started with the Bongo district. That was the first place we discovered high fluoride. And then Timothy worked actually in the Gushegu district, but trying to see how it can actually be, the water can be used for irrigation purposes. So there are future directions. We need to have enhanced data integration and analysis. Now you've seen that most of the works we've done, we've not even integrated AI. So this is something some of you who are good in AI can come in for us to do. We can have interdisciplinary collaboration. So we all bring our ideas together and we do this. Policy regulation. With what we will get, we can actually tell the government of Ghana as to what to do. Then we can educate people like what we are doing, this webinar. Perhaps some of the things I've said you didn't know about them, but through medical geology, we can do all this. Technological innovations. You see, we have now even developed a medium or technology for defluoridating the water. This is what medical geology can do. Research and development. We are publishing a lot of works and people are seeing, and that is what is helping us. So in conclusion, medical geology plays a pivotal role in achieving the SDGs. And it does that for us to have good health, good life. And this will enhance public health. It will promote sustainable practices. And now the governments of the day can actually churn policies out of what we are doing. It will also advance education and awareness. People will be well informed about their geological environment, what it is doing to them. So we have ongoing researches that you can partner with us. My research is basically hydrogeology, environmental geochemistry, and mining geology. So these are the things I'm doing. So you can partner with me. And then my research group at UMAT. Currently, I'm off UMAT on very soon. It will be official because I'm in India right now. And so it doesn't matter wherever we are, we can do such works together. So I would like to thank the University College of Water Science and Engineering for the invitation to this webinar as a guest speaker. And I'm looking forward to a lot of collaborations with you and with other people who have joined. I thank all my team members for their dedicated works. Thank you.
Wow, thank you very much, Dr. Sankari. This was a really insightful session. Even with regards to the limited time we have, you were able to go into a lot of details. And for some of us who are new to this field, we've learned a lot. And so due to time, we can only give 10 minutes for our Q&A. So I indicated earlier that for those who would like to ask questions, you can either raise your hands or you post your questions in the comment section. I can see Dixon Ama's hand up. So in case you have a question, please unmute yourself and go ahead. Thank you.
I'll be hearing from you.
Hello, Dr. Sankari. You can stop your sharing.
All right.
There's a stop presenting, yes.
Okay.
Thank you. Hello, Dixon. Are you still there?
Yeah, thank you, Prof, for the presentation. And my question was based on some of the carcinogenic element from the soil. Then looking at how possible can we group some of these things in case of like decision making, so that it can also help, because in all we are trying to bring them out and also make our views and also through publications. But can we also have in such a way that in the field of medical geology, with the help of public health, with the carcinogenic element that cause a whole lot of chaos to human lives, we can also give it to policymakers. In case of that, what can we do to achieve in that stage? Because if they are causing effect, because we don't know, but it's only maybe few people who are geologists or maybe medical geologists, and it is a new field that, as we were talking about, that it's also coming up. I think most of the sources we give the source. So in case of policy making, what can we do so that we can also give it and also prevent a whole lot of, because I know one day it will cause a whole lot of danger to people within these areas.
All right. Thank you so much. So, with the question you've asked, yes, we conduct research to help policy making. So, with this research, you have realized that we have identified fluoride as a problem in groundwater. Arsenic is also a major problem. Arsenic is, I mean, in terms of carcinogenic elements, we have arsenic, we have cadmium. These are the elements that can cause cancers, even mercury. They can cause cancers of various degrees. So what we do is to inform the policymakers, make presentations to the governments of the day, the district assemblies. But unfortunately, as I indicated, there was a time somebody asked this question, I think the last webinar. We always do all these things, but the governments of the day don't see the need to invest into what we are doing. Except when they see that people are dying and then they are on their throat, that is when they begin to act. Because as of now, we don't have a defluoridation plant in Ghana. Meanwhile, we have identified the northern part of Ghana as a fluorosis endemic area. So we should have a defluoridation plant, but nothing is being done. So that is why I think some of us who are researchers should delve into politics. So when we go into politics, we are the ones who can help implement some of these things. If not, we will just be pouring water into the drain. So I think that is what I can say.
All right, thank you, Prof. I can also see Prof. Chuk's hand up, so please unmute yourself and ask your question. Thank you. Hello, Prof. Please, are you there? Prof. Chooks. Okay, Mr.
Very much here.
Okay.
Yeah, good afternoon, my brother. That was a very good lecture. Thank you so much for highlighting the role of medical geology. Now, my question is, you have a research group. To what extent is your research group multidisciplinary? And how open is it? Is it only within the University of Ghana, your University of Mines there, or do you have other researchers who work with you? Because I think it might be good for you to open up to those in the biological sciences so that they can also do some work with you and get their perspective, so that the perspective is just from one side, because that's where policymakers will listen. Then you also need to get some social scientists to help us understand the social factors, because sometimes social factors drive these things. There's a community in Nigeria that I know. When a woman gets pregnant, she has to take alcohol every day. It is believed that when she consumes alcohol every day, her delivery will be very simple. And we all know the effect of alcohol. And then they're not trying to link it to violence among children born in that area. In Nigeria, we know that they are one of the most violent areas in Nigeria. People are saying, I mean, a child that has taken so much alcohol for 9 months, what do you expect when they are born? So there's always a social perspective also that I want you to bring into. If you can bring social scientists, environmentalists, and people from the biological sciences, I try to make a lot more impact to your work also. Thank you.
That's great. I think, Prof, that is a very good recommendation you've made. So I will take it up. Initially, the research group was just based in UMAT, where I am a lecturer, and I was just dealing with my master's and PhD students and undergraduate students, and also some lecturers. I have some lecturer friends of mine who are also into these kind of research, especially environmental engineering. Yeah, but as you said, it is right. I'm going to open it up to everyone who can join and contribute, especially the social scientists. We need their contribution. And they can help, like you said, drive it towards the policymakers very well to us.
Okay, thank you, Doc. There's a question in the comment section, from Michael. He says, please, what is the research direction and way forward for Ghana and other African countries where illegal small-scale and large-scale mining is on the rise, affecting natural resources like water bodies and soil, negatively causing serious impact on humans and ecosystem biodiversity? He wants to know what is the research direction and way forward in such a situation.
That is great. So I think we need to do more research to know the impact of these mining activities on our environment, especially water and even the soil. Yeah, we have reported cases, especially of the artisanal small-scale mining, but there are also some instances where the legalized mining is even still giving an impact to the environment. There is a paper that is coming out very soon. With my students, we have done a review of water quality, the impact of mining on water quality in the whole of Takwa. And you know, Takwa in Ghana is the hub of mining. The whole of West Africa is the only county or the only city or town that has the highest number of mining companies. So it is actually affecting the quality of our water resources. So we need funding to do more research. Wherever you have a mine or you have artisanal small-scale mining activities, we, the researchers, have to also go in and do research and advise them. It's not only about doing the research and just tell, oh, this one is high, this is this, but we need to advise them as to how to bring back the earth or the environment into its previous pristine value. So I think we need to still start churning researches towards that direction: water quality, soil quality, and even human health.
Thank you, Doc. Stephen, in case you're still around, you can unmute yourself and ask your question.
Okay, so first of all, I would like to thank you, Doc, for such an insightful presentation. And I've learned a lot today. So my question is, in your presentation, you made mention of the fact that in some areas in the northern part of Ghana, like Gushe, we have the presence of fluoride in the groundwater. So my question is, in these areas that have high fluoride levels in the soil, how can the communities safely dig boreholes without actually risking fluoride contamination in the water? And then again, are there cost-effective treatment method for these people in that area? And again, the follow-up question is that I'm currently studying environmental engineering, my final year in the University of Energy and Natural Resources. So my follow-up question, after completion of school, can I decide to, enter into the field of the medical geology? So that's my question, Doc.
All right. Thank you so much. So let me maybe address your last question. Yes, you can go into the field of medical geology. Actually, there's no specific course in a university called medical geology. That one I have to let you know. You do it under a branch of geology, or maybe just geology in general, then you focus on medical geology. Or you go and do environmental geochemistry. Right? As an environmental engineer, you would have even done environmental chemistry as a course, environmental geochemistry. So that is just medical geology. All right. But in that aspect of medical, or with respect to medical geology, we are only looking at the environment, the rocks. We are not looking at anthropogenic things. So you can go and do environmental geochemistry at the master's or PhD level, or geology or environmental geology at the master's or PhD level, and major in medical geology. So it is not a problem. You can do it. Now, with respect to the first question, yes, we've identified the northern part of Ghana as the fluorosis endemic part of the country. And yes, if they drill borehole, because the rocks are the ones that are the causative things for the fluoride enrichment, there is nothing we can do. We cannot just take the rocks away. All we have to do is treatment. When you drill a borehole, you can expect that you will get high fluoride. But now we have tried to correlate the fluoride values with borehole depth, the depth of the boreholes. And we have realized that the lower the depth, the less the fluoride content. But that is also a problem in the north. If you don't drill borehole up to 100 meters, 70 meters deeper depth, you won't get water. Go to northern region in Tamale. That's a big problem in the Voltaire. So that is why we are saying you will still encounter the fluoride no matter how you drill over there. So we need to put sustainable mitigation measures. That is why we have looked at cost-effective ones, household ones. Like moringa we talked about. Moringa is all over in the north. Every house you go, they have moringa in their farms or backyard gardens. You can harvest the moringa, the seeds, okay, or even the leaves. You dry them, powder them, and then you can pour them into the water, allow the water to settle for a while, let's say 2 hours. Then you can filter it. It will coagulate all the fluoride and even some metals. The research has proven that even some metals like arsenic and all that, cadmium, are all being trapped by this method. So this is a simple one that the household can do, or activated cow bone. So that's why we are praying that we get funding so that we can do this on pilot base. The cow bone we have activated, we can distribute it among the fluorosis endemic parts so that they can add to their water and filter the water thereafter and drink. Or the government itself has to go and put a defluoridation plant in the fluorosis endemic parts, and then the water can be treated before it is distributed to the people. That is the best alternative we have as of now.
Thank you
Thank you,
very
Doc.
much, Doc. So the next question in the comment section is, congratulations on your presentation, Doc. Please, I would like to ask, can you do anything to increase the amount of an element to make it adequate to reduce health risks? Like you can do something to reduce the quantity of fluoride, like you said, about using bone to treat higher fluoride content.
Can you do anything to increase the amount of an element to make it adequate to reduce health risks like you can do? So it is a very dicey question, because if you have fluoride in the water, the only thing one can do is to maybe send something down that can, how do you call it, substitute for the fluoride, or can actually, eliminate the fluoride in situ. That is the only option that we can look at. But I don't know any technology that is available, especially in Ghana, that we can do it in situ and eliminate it right there. But what we can do is just pumping the water. Yes, the water, we've pumped it, it has high fluoride. Then we defluoridate it through processes. There are defluoridation techniques, as we talked about, the adsorption techniques using the moringa, using the cow bone, or research has proven you can even use bauxite. You see this ground, the bauxite bearing one, you can use it to remove fluoride. All right, and even biochar can be used to remove fluoride, or coconut husk. The coconut husks, we eat coconut and we throw the husks away. The back of the coconut, you throw it away. You can use it to produce, a coagulant which can help in reducing fluoride and other metals. That's the only thing we can do ex situ, but not in situ.
Thank you. So
Yes.
we have last two questions. So from Abdul, in case you're still around, you can go ahead. When he's done, Shadrach, you can also ask your question.
Yeah, thank you very much, Prof, for your wonderful presentation. Actually, this is my first time participating or getting to know something that has to do with medical geology. I'm currently doing my master's in GIS and remote sensing.
Wow.
In China here. Yes. So from your presentation, I have understood that this medical geology, if we don't have attention on it, it can lead to a lot of water quality and health issues in the country. But then I have questions I want to ask. Do you see a need for international frameworks or policies dedicated to medical geology, similar to these climate change agreements? If there is, has the government of the day or the country responded to it? That is my first question. And the second question is, what strategies can be used to improve interdisciplinary collaborations between geologists, healthcare professionals and policymakers. And the last question is, from the ending part of your presentation, you mentioned AI and big data analytics. So I want to ask, how can AI and big data analytics enhance medical geology research for better disease prediction and prevention? And how can we let this descend into the various courses that we study from the universities, and then the government can also take it on for the development of the country? Thank you.
All right. Thank you so much. In fact, these are questions that are so relevant to us. So now, the last question, how can AI and big data be used in data prediction and all that? So if you check over the years, especially where you are coming from in China, they do a lot of these research works. This issue is also in China. Fluoride issue and nitrate issues are also in China. People are using AI to predict the quality of the water. Based on what we know, they are able to use AI with the chunk of the data we have to predict in the next few years, the next few days or weeks or months, how much fluoride we are going to have or how much arsenic we are going to have. So AI can help us in predicting the future. We will get to know the quality of the future for us. All right. So we don't have the requisite resources to go and do laboratory analysis every now and then, so that we analyze, we know. It's very expensive. But with the known, or with what we have, and based on some parameters we know, the trend or pattern of activities within every locality, we can use AI with the chemical data and predict what will happen in the next few years. So that is how AI is going to help us. And in fact, in terms of research, that is what even the journals are encouraging for us to do. Incorporate AI and big data, machine learning, and all that into our data analysis and prediction. Now, you also talked about collaboration. Yes, we need collaborative efforts to be able to deal with this menace. You can't do this alone. For example, the lab analysis was done by a chemist. I'm not a chemist. I'm a geochemist. I am only interested in interpreting the chemical data. But how to get the data is the chemist that will do it in the lab. So we need collaboration. We need, like Prof. Chuk said, we need a social scientist. When my student had to go to the, he's not a social scientist, but we had to design questionnaire for him to go to the field and ask the people about how much water they drink. Have they encountered any problem with their body or whatever as they are drinking the water? All these things, if we had experts in those areas, in fact, we will churn out quality research works. Now, you ask whether there is a need to have international frameworks. Yes, there is already. We have even UNESCO chair for medical geology. When I went to South Africa, the person I first worked with was the chair, and currently she's still the chair of UNESCO, branch of medical geology. So Professor Hasina Mori, now she's the chair, the president for IGS, International Union of Geological Sciences. So there is policy framework available, but it is meant for us to imbibe it. Most of the countries don't see it to be of relevance. So, for example, my country, Ghana, sorry to say that Ghana has not taken it to another level. But for Nigeria, I can clap for Nigeria. To be frank with you, right now, we are bringing the Center for Medical Geology to Nigeria in West Africa. So very soon, they'll be doing master's and PhD programs in medical geology. All right? This is something Professor Emmanuel Daanoba, one of my mentors in this medical geology, he told me about it. Because Ghana lost, but Nigeria is doing very well. We also have this issue. So medical geology is thriving very well in West Africa, especially in Nigeria, than in Ghana, because politicians and policymakers don't see the relevance of it. All right. And there are a lot of research funds that are available that we need to write. As we have collaborative backgrounds or different disciplinary backgrounds, we bring our ideas together and we can get a very good proposal and write to grants, funders, and then they will give us the funds to do our research. So I think I have answered your question.
Thank you, Doc. So Shadrach is the last question due to time, and I think we lost him. So Doc would like to thank you. In case anybody wants to reach out to you, how can they do so?
Yes, I think Shadrach is back.
Okay, so Shadrach, you're the last person. You can go ahead and ask your question. You're running out of time.
Hello.
Hi.
Hello. Yeah, please can you
Yes,
hear
we
me?
can hear you.
Yeah, so mine is just a contribution. I think my boss has said it all, but even along the line, he made mention of that. He made mention of when somebody asked a question concerning the cost-effective method, and he said we can even use bauxite. I had just wanted to make a contribution. Yes, so in Ghana we have bauxite, and there is a portion of the bauxite we term it as laterite. When you use the concrete lateritic material, it can do that because when I was a student those days, we looked at a column where we're trying to remove arsenic from contaminated water, and that concretic lateritic material did that for us. And since arsenic in water behaves like a negatively charged ion, it also means that once you have fluoride, as Prof said, um, basically that oxide part in that concretic material should be able to also remove the fluoride. So that is just a contribution that I want to make, because we are in the same group, we've been working together. So it's just an add-on. That is what I wanted to say.
All right. Thank you so much, my boss. So I think, Hetty, you asked me a question. How will
Yes,
people
Prof.
reach me out?
Yes.
Yes, so I can give my personal email in the chat box. So anybody that wants to reach me out can get in touch with me or through your university. You know, I'm part of you.
Of course, Doc. Thank you very much. And I believe they can also follow you on LinkedIn as well to
Yes, so if you
get
go to
information.
LinkedIn, just type my name, Emmanuel Daanoba Sunkari. You can follow me. Facebook, the same, and Twitter, the same, or X, yeah, and then Instagram, the same. You will see me.
Okay, thank you so much, Doc. So, just a few announcements. We have an upcoming webinar on the 31st of March, which is the topic is tracking progress towards sustainable intensification. You can get more details on the UWSE pages on LinkedIn and Facebook. Also, we are looking for volunteers for these international events, which is World Water Day for March 22nd, World Food Day for October 16th, and then World Day to Combat Desertification Drought, which is June 15. You'd also find information on our LinkedIn pages and Facebook, so you can register as well. So, Dr. Emmanuel Daanoba Sunkari, I want to say a very big thank you. It was such an insightful session, and I believe everyone has picked something. And this conversation has got a lot of people thinking, and I'm very sure you might receive a lot of um, messages concerning people who would like to join the great work that you're doing. Would also like to thank everybody for joining this session, and we hope to see you in the upcoming ones as well. Thank you.
All right, so thank you so much. I appreciate the efforts Prof. Amoba for bringing me on board.